Hello, my friend. How you doing? Well, it's been 2 weeks since the last time we met, and yeah, first of all, I apologize for um getting out while we are still in a session because honestly, last time, as I mentioned before, I was just from home, just got from home from the gym, and it was so totally drained. And yeah, one more time, I apologize for letting you along. And this is the reason why I'm here today to get and to end the thing that we have started last time. So, did you remember the time, just the last time, the former time we talking about? This is about 4.1, right? Section 4.1 of our lecture 3, filter functions. So, today we just have only two small parts. First of all, 4.2 scan field view and display field view. And the second thing is image center. So I'll be quick for you. I'll be quick for you. And yeah, I'll go on today. The reason why I came here to end the thing that we have started last week. Alright, let's go. Lecture 3, Image Reconstruction, Part 3. So, So, let's see what we got. Field view, my friend. Field view. You will hear the term field view all the time, right? But the point is, my friend, I want to introduce you two main definition. I think two main exact definition of field view. First of all, scan field view, and second of all, display field view. What is it? So I have highlighted the definition of each one for you in here in this box. So scan field view determines the area within the gantry from which the raw data are acquired. And the section and about the display field view, is a section of data selected for displaying on the image. So simply, we can call scan field view is a thing, is the area you want to scan, you want to get an image, you get a raw data, yeah? And the display field view is the area you want your image display. Just that simple. So first row, basic row, the display field view must to be smaller scan field view, right? Right, my friend? It's simple, right? Because, for example, if you got a scan field view of 50 centimeters, you can display about a 55 centimeter field view. Why? Because data from the outside, you can't have it. You don't have the data from the outside, you scan field view and display it on your image, right? That's the first thing. First row, you won't have a display field view larger than your scan field view. And the second thing I wanna note here, I think many people make mistake about this thing. So you change, my friend, you change the display field view. The changing display field view is totally, my friend, it's totally different from you zoom in the picture. Yeah, I believe I have mentioned it before on this lecture on I think in the previous sessions. And yeah, let me show you, okay? So first of all about the multi-detector CT, you can have the scan field view depends on the width of your fan beam. Okay, simple, right? If you want a field view about a centimeter, 50 centimeters, it will be need a fan beam, larger fan beam than the about 30 or 25 centimeters field view, scan field view. So that's the first one. That's the first one. And the second one is, my friend, the second one. So this picture, the A is the field view, the scan field view. Okay, all right. So which means you take the data of the flower. This is the scan field view, the whole flower. And the point in picture B is our display field view, which means you use data in this and you display only the area you want right here. So this is the display field view. So what is the difference between change the DFOV and you zoom in the picture? So the main point why you change the FOV, you change the pixel size. What is change pixel size? So we'll do some little simple calculation for you. All right. Okay, let me do something. How can I stop it? I can stop it. So let me show you, all right? Let me show you. So you change the pixel size equal pixel size equal let me see, the field view, the scan field view, scan field view, scan field view, you you divide it by the matrix. So the FOV, I'm sorry, instead of FOV, in this case the FOV, which means the DFOV, all right, and you change the DFOV means, for example, this time you want a smaller DFOV, means you smaller the pixel size, my friend. Yeah, you smaller pixel size. And what does it mean? The resolution of your picture. Why are you using? Sorry, let me show you. So this is if you use the DFOV to change to create your image, you will have the image that whose the pixel size is different from you use. Let me show you. You use the FOV, scan FOV to create that image. Yeah, you can see that, right? So there's no matrix because the SFOV will have the larger pixel size. So when you zoom in the picture, your image quality will not great as you use the smaller DFOV to create the picture. So that's the first of all. And yeah, that's first of all. And main thing, sometimes usually I see people make a mistake about this term, these activities, and I hope I have made clear about this for you. That's the first thing. The second thing, my friend, I want to make clear in here, right here, is just like the first rule I told you. Yeah, the SFOV, the scan FOV, have to be larger than the DFOV. So the simple question to check your understanding about my term. So if can we have the picture B with the raw data of the picture A? So my friend, you got 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, my friend. So the answer is simple, right? You can have the picture B with the raw data, the picture A, because obviously, apparently, the picture A is just a small part of your body, small tissue, your body part, and you have no raw data about the outside tissue. So that's the reason why you can't have the picture be then after that, because simple, you have no data and you don't need to remember it, learn by heart, because your computer will notify you about the error, this error, when you want to create the picture with a display FOV larger than the scan FOV. Yeah, just that simple. So that's it. 4.2, scan FOV and display FOV. All right, let's go to the 4.3. 4.3, I'm sorry. Let me check it out. Let me fix it, okay? 4.3, image center. So what is image center? Image center is such a... Did you remember the time? Remember the time I told you about the laser system of the city? Yeah, okay. I think you get it. The laser system, the main point of the laser system is employed in the city gantry to the main thing, the main point to allocate, my friend, allocate your point, your setting point. So what is a setting point? Let me show you. So you need a setting point to how can I play it? Like the coordinate I am talking about right here, the image center. Yeah, you got an image center. So the setting point is the 0 point, which is determined by the cross section. Yeah, the junction of the laser, the vertical laser and horizontal laser line beam. Yeah, you got 1 point, and that's a 0 point, and you use that point to, and you set that point to a 0 as a 0. So for the x and y, I mean for the from that point you got a 0, and you can apply, my friend, you can apply the coordinates to determine the location of the tissue you want to take the picture, just like that. So first of all, I can show you what x, y coordinate, or you can call it Cartesian coordinates, right? So it's applied. This coordinate is, I think it's a very common coordinates because everybody knows it, because everybody, just like 2D coordinate, I will call it 2D coordinates. All right, yeah. For example, your laser beam, the coordinate right here, 0.0, 00, x, y, 00, respectively, 00, and you want this kind, you want to take picture of the kidney, and if you just move your mouse, to this point, yeah, will display you about, I think it's about negative, usually, yeah, negative x value and a negative y value. So for example, so -1 point. So that's it. And this is the picture below is about the, I would call it, for the simple, yeah, the simple call, we could call it 3D coordinate system, and you would call it more formally RAS coordinate system. So what is RAS? What does RAS stand for? It stands for right, left, anterior, posterior, superior, inferior coordinate system. So simply you can imagine that you could call it the 3D coordinate system because it helps you to get a point in the 3D dimension. Yeah. So for example, if you take into account the, the thickness, yeah, the thickness axis of your body part. So for example, your kidney, for example, this, you just see your kidney in the 2D dimension, but the kidney is a kind of in a 3D object, right? So it kind of thickness, and you want to dive into, you want to check it out, you check your kidney out per slice, yeah, per thickness. You're gonna throw from a superior of your body and into the inferior of your back, from to inferior of your back. You gotta need more more axis, and we call it 3D axis system. For example, if we got let me show you. We need the axis. Let me draw it for you, alright? Let me draw it for you. I need a pen. All right, we got a more axis. I will call it axis of the thickness. The z-axis, maybe you want, if you want to call it, yeah, z-axis. So this axis. So if your kidney, you want to look at your kidney more deeply, yeah, you gotta dive into it. So what is our part right now? For example, it will be a negative x value and a negative y value. And this time, because this is 0 point, and above it, we got a positive z value. But because we want to dive deeper, so more deeply, so our value will be a negative y value, a negative x value, and a negative z value. For example, -1, -1, minus 2.5, just for example, centimeters, just for example. So that's the point of image center, and that's the point, and that's how our image center, our image coordinate correlate with our laser system that I have mentioned before, just like that. So this is our two session I want to discuss today to end our lecture 3. So the third one, I apologize for quitting last time because I was so drained, my friend. Honestly, yeah, you just imagine you've worked for our what is 6 days a week, and you just want one day to go to the gym, keep fit, and yeah, you gotta do something about your passion, talking about knowledges, sharing it to every person, and yeah, sometimes it's just overload for me. But yeah, don't worry for me. Just get back to work. Just yeah, I'm right now full recovery. My body right now is great, and that's it. I think I just finished my task today to accomplish the two remaining part of our lecture three, part three, which is also the last part of our lecture three. So we're going to the lecture four in the next week, I think. And in lecture four, we will talk about image display, one of the most, I think, the most interesting thing that thing to, especially for our technicians and yeah radiologists, because we'll talk about the house field unit, the grayscale of our image and how we modify it. And the main part is because the reason why the image display lecture is so interesting, is so intriguing to the radiologist, because is mechanism just relates strongly to the clinical things we do every on a daily basis. So you change the house field unit, you change the grayscale, you change it all the time, right, my friend? So we will talk about the physical background of our activity in changing, in modifying the grayscale of the image, CT image. Next time, my friend. Lecture 4, image display. Yeah. And I hope you will wait for me. I'll get back to you, my friend, just like this time. Thank you very much for listening. I'm Long. Goodbye. Have a good day, my friend. Hope your day goes well.